भाई, हाँ हो गया हो गया।
Okay. Okay. Yeah. So welcome. Good evening, everyone. So I welcome you to this class on heat transfer. So my name is Varad Dau. So I am a PhD student at the Department of Chemical Engineering at IIT Kanpur. So to give a brief about myself, I've completed my BTech in Chemical Engineering from VNIT Nagpur in 2019. After that, I worked in a private organization, Reliance Industries Limited, for about an year. Then from I think 2020, I took admission into IIT Kanpur, and now I'm a fifth year student and almost at the end of my PhD. Okay, so as far as since Shayank has told me that you guys are very interested in GATE, so this course would be mostly GATE based. So we'll be solving questions as well as trying to understand the concept also. And to give a brief background about my GATE journey, so I think 2019 I gave my first attempt. In that, I think I scored around 1200 rank. Then 2020, I again gave an attempt. In that, I scored I think 900 something rank. And in my third attempt, I scored AIR of 300. Okay, so just give a brief about myself. Okay, yeah, just a minute. Okay. So I welcome you all to this heat transfer class. Okay, so this is the class. So we are going to cover. So first, I will just want to introduce what is a
भरत,
transfer. बता. Yes.
ये लेफ्ट कॉर्नर में तुम्हारी स्क्रीन पे या किसी स्क्रीन पे कुछ है क्या?
Now you can see. अच्छा
आईपैड पे।
ये. Okay, okay, yeah, like this.
कैन हटा सकते हो उसको?
अच्छा ये.
हाँ 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 हाँ।
This is
फाइन।
okay. Okay, okay. So today's class will be a introductory class. Okay. So let us first try to understand what is heat. So when we say heat transfer, first let us try to understand what is a transfer. So transfer, what is the meaning of this transfer? Okay. So transfer involves movement of certain quantities due to interaction of the system with the surrounding. Now, what is system and what is surrounding? I hope you have done this thermodynamics course, in which what we know that system plus surrounding is nothing but the universe. So whatever we are trying to do, the transfer, heat transfer, we are trying to study inside the system. Okay. So
भरत
all
अभी
the
हीट ट्रांसफर का कोर्स किया नहीं है इन लोगों ने।
na
ओ सॉरी,
thermodynamics.
थर्मोडायनेमिक्स थर्मोडायनेमिक्स नहीं किया अभी।
So
सेकंड,
thermodynamics. Yeah.
जहाँ तक लोग सेकंड ईयर में।
So okay. So let me just add a page. Yeah. Now what is heat transfer first? Okay. So what is? So let us consider that you have.
पिंग पोंग बॉल तो बॉल होती है।
Sorry. Come again.
वो गलती से हो गया शायद।
Okay. 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 So we'll start with what is system plus surrounding. Okay. So let us consider that this is some piston cylinder arrangement. Okay. So now what is this pressure is P atmosphere. Okay. And let's say there is some gas. Some gas is there inside the system. So now what we want to do is we want to understand how the, let's say, volume, temperature, pressure of this system changes of this, let's say, this area or this volume changes when we increase the pressure to, let's say, PATM plus delta P, right? So now the piston will move downwards, right? Let's say if we are trying to increase the pressure, okay, so this will be the new position of the system, right? So now the volume changes to volume plus delta V, temperature changes temperature plus delta T, and pressure changes to pressure plus delta P, right? So now, so what we consider is this is our system. Whatever we are trying to study that part of the universe in which we are interested in calculating the property. So this is what we say our system, and everything outside the system, everything outside this, everything whatever is come, that is nothing but surrounding, right? That includes this piston, whatever air, whatever everything. So that is why we say that system, which is nothing but this part, right? This yellow orange part plus surrounding is nothing but universe. Okay. And what we are trying to study is whatever heat transfer is occurring inside the system. We are only concerned about this part of the universe. That is what system. Okay. So that is, you don't have to go in detail what is thermodynamics and all. Just understand that this is what we are trying to, we are interested in finding properties. Okay. So now transfer. So yeah. So now what is the transfer? Transfer is, in simple words, we can say it involves movement of certain quantities, right? Movement of certain quantities due to interaction of the system with the surrounding. Okay. Now what drives, now the first question which you which comes to our mind is what drives this heat transfer process? What is, why does heat transfer occur? Then what drives this heat transfer process, right? What is the driving force for transfer of for any type of transfer, heat transfer or momentum transfer? Here we see the driving force for momentum transfer. Actually, Shank will be, I think he's going to teach in fluid mechanics. And the driving force for momentum is nothing but change in pressure, right? The driving force for heat transfer is nothing but change in temperature. Driving force in mass transfer, which I think you'll study in third year, is chemical potential. So chemical potential is nothing but partial molar gas free energy. So that we will study. Okay. So driving force is temperature difference if it is heat transfer, and it is chemical potential, right, if it is a mass transfer. So heat transfer temperature difference is generally referred to as delta T. So the convention of saying that there is a driving force for heat transfer is nothing but delta T. So T stands for temperature and delta stands for difference in temperature. Okay. So now the question immediately arises as to what causes this driving force. The driving force may be actually be naturally created. Yeah. So driving force could be naturally created, or it could be man-made, or in other words, it could be engineered. For instance, we may have a slab which is actually maintained at different temperature, right? For example, like this, we can have a, let's say, a slab like this. This is a solid slab. Okay, this is a solid slab. Okay. And now we are maintaining one phase of this solid slab at temperature T is equals to 2E1, and another at, let's say, T is equals to T2. Now let's say T1 is greater than T2. Right? So in that case, because there is difference in temperature, here temperature is T1, there is temperature T2, and the driving force then becomes T1 minus T, right? So that is why there is going to be transfer of heat from this end to this end, like this. Okay. Right. We may have a slab which is actually maintained at different temperature, and one end is at a temperature T1 and another is at T2. Okay. So because of this, heat transfer occurs. So now the question again arises is, what are the important transfer processes? There can be transfer of momentum, like I said in previous slide. There can be transfer of momentum, transfer of heat, and transfer of mass as well. So now in this course, what we are going to study is, we are primarily going to focus on heat transfer and okay. So now let us look at what are the objective of this course. Okay. So the primary objective of this course is essentially to quantify heat transfer, right? So first of all, we have to understand how this heat transfer is occurring. Once we know how heat transfer is occurring, then why heat transfer is occurring. Then once we know both of the answer to both of these questions, then we have to quantify as to how much amount of heat is transferred, right? That is one of the objective of this course, is quantify heat transfer process in various system. In particular, we will start by looking at various terminologies, right? So what are the different terminologies? What is temperature profile? What is driving force? What is the flux of heat transfer? What is the rate of heat transfer? So these are all the different terminology which we should understand in order to study quantify heat transfer, right? So the physical principles involved in heat transfer process will actually be described. So we will be studying all these things, right? Physical principles, why heat transfer occurs, so on and so forth, right? And we are also going to study heat transfer phenomena in various systems. Let's say, for example, one system of interest could be, let's say you have a furnace. Let's say here iron is getting converted to solid to liquid, something called as a blast furnace. Okay. So now we are going to heat the system, right? So now we should also make sure that there is no heat loss is very minimum, right? Because ambient temperature is going to be, let's say, T1 or T infinity. So we'll use the convention T infinity. And let's say these walls are at temperature T1. And let's say T infinity is less than T1. So because there is going to be temperature difference, heat is going to leak out from this system, right? In this direction. Now, what we would want to do is we would want to minimize this heat loss, because the higher would be the heat loss, the higher would be the energy which we would require to supply, right? So we would want to minimize this, loss of heat. So the one way of doing this is you cover it with layers. Let's say the walls of this things you cover with layer. Let's say this is of some material, insulator. Then this will be surrounded by another layer, right? So that heat loss. So now what we need to do is, what should be the properties of this material? Properties, right? What is the property of this material? What should be is, thermal conductivity. How much amount of resistance it should offer to heat transfer. So this is a potential one system of interest which we are interested in looking at as far as heat transfer is concerned, right? Particularly, we will be looking at the fundamental aspects in each of these cases, and then we will be looking at quantification of heat transfer in this process. Okay. Yeah. Quantification of transfer. Now, so we will be looking at the quantification of heat transfer phenomena in each of these systems. Like one of the system, this is one of the sample system. So we will actually be able to write models. Now, how do you quantify the heat transfer within this thing? Right? So there should be a model, right? How do you quantify heat transfer occurring from wall of the furnace to the fluid or air, you could say. So how do we quantify, what should be the way of modeling this thing, right? So that different models. For example, here would be this what is it called? Heat conduction, that delta T is equals to sorry, Q is equals to minus K A into dt by dx. So this is one way of modeling heat transfer. Another way is Newton's law of cooling, which says that Q is equals to HA delta T. So now we will try to see as to how this equation arises. What is the fundamental nature of this? As to why with this equation we can model the system. Okay. Further, we'll also try to understand what is the local and average heat transfer coefficient. So this is very important topic, right? What is the local heat transfer coefficient and average heat transfer coefficient? So we will be trying to understand this, right? And then analyze the model and the behavior of H and H cross. So whenever I say, so convention which we are going to follow is, whenever any quantity where there is one bar, that means it's average, right? If and if it is if there is nothing, then it's going to be, this is the thing. But if there is one dot, then it is rate of whatever quantity, rate of quantity.
Bharat,
Okay.
when you are saying about the models, so are you limiting yourself by these two models, or any other model you are?
No, so these are the only two models. Like for example,
But I think first one is for conduction, one for is for convection, and
yeah,
third one is are you going to cover radiation?
yeah,
In
yeah,
which,
yeah. We are so I'll tell what topics I'm going to cover in the subsequent slide. So this is just one of the model. So this is the way by which you can model conduction. This is the way by which you can model convection, and there are other methodologies or other ways of modeling irradiation as well. That also we are going to cover. I just gave it as an example. Okay, I can proceed, right?
yeah, fine.
Okay. Yeah, yeah. So where was I? Yeah. So whenever there is bar over any quantity, we are going to say that it's an average quantity. Whenever there is a dot over quantity, we are going to say that it's a rate of quantity. And when there is two dot, it is flux of quantity. So we'll study what do you mean by rate, what do you mean by flux, what do you mean by average? What is this mathematical formula for it? So that we are going to study. Yeah. Now, heat transfer actually is a ubiquitous phenomena, which is actually seen in many different processes, right? In different industries. So understanding the heat transport phenomena is actually very important in characterizing this unit operation, particularly in terms of saving cost and transporting heat between different fluids, right? It's like I said. Yeah. So what is heat transfer? So we are also going to study, okay, this is also important that heat transfer can occur in multiple phases also, right? That is an example would be boiling. Whenever you have a utensil and inside it you keep water, and when you heat it, after some time that water is going to convert into vapor. So that also we are going to see. That is the phenomena is boiling and condensation. So that part also we'll see. So I'll just go. Yeah, like I said, different modes of heat transfer. There is a conduction, there is convection, and there is thermal radiation, or simply called as radiation. Okay. And heat transfer, like I said, can occur in one phase or in multiple phases, and it may also involve phase change. Okay. Yeah, so these are I already explained. So maybe sometimes I use dot or sometimes I use this prime also. So whenever we say Q, that means rate of heat transfer. Sorry, this is only transfer. This is not rate. This is only heat. Heat we are saying. Whenever we are saying Q dot, that is rate of heat transfer per unit length. Okay, and Q double dot is rate of heat transfer per unit area, which is nothing but flux. Right. So when we say unit, इसका unit होगा watt per इसका यूनिट होगा जूल पर सेकेंड, दैट इज नथिंग बट वाट. ठीक है, इसका यूनिट होगा जूल पर केल्विन इनटू लेंथ विच इज वैट पर मीटर, और इसका यूनिट होगा वैट पर और जूल पर केल्विन लेंथ स्क्वायर विच इज वैट पर मीटर स्क्वायर. राइट. So the way these quantities are related is sorry. The way these quantities are related is Q dash is nothing but Q by L. ठीक है. Q double dash is nothing but Q by L again, Q dash by L, which is nothing but Q by L square. Okay. This is how, so this is one form of, yeah. So let's say, yeah. So conduction, what is the conduction phenomena? So conduction phenomena mostly occurs in solids. So in this, for example, I said, this is a slab of some material, right? Stationary medium. It could be solid or liquid. And let's say we are maintaining the temperature of one side or one phase at T1, and at another phase T2. And let us assume that T1 is greater than T2. So because of this, heat is going to transfer from this temperature T1 to temperature T2. Okay. So this is conduction. Right?
Bharat, what is happening to other walls?
Yeah, so we are going to assume that its cross section is same. So there is no, for example, you can say that यहाँ पे जो है, यहाँ पे there is no heat loss. ठीक है. There is no heat loss from here. So heat transfer is this is a classic example of 1D heat transfer. ठीक है, समझ रहा है ना. 1D heat transfer, actually 1D steady state heat transfer. 1D steady state heat transfer. 1D क्यों है? क्योंकि ये इस डायरेक्शन में ही हीट ट्रांसफर हो रहा है. ठीक है. अब तुम दिस इज लाइक वी आर ड्राइंग अ 2 डायमेंशनल पिक्चर, लेकिन अगर 3 डायमेंशन में आप देखोगे क्यूबॉइडल शेप में, तो ये एक जो फेस है इसका, दिस इज एट वन टेम्परेचर एंड दिस इज एट अनदर टेम्परेचर. सो इन प्रिंसिपल हीट ट्रांसफर कैन ऑकर इन दैट डायरेक्शन ऑल्सो, जेड डायरेक्शन में भी हो सकता है. राइट. बट whenever we say that it's a 1D transfer, that means एक ही डायरेक्शन में हीट ट्रांसफर होगा. So that would be a simple case of 3 dimensional heat transfer. So we'll study, for starting we'll study with only 1 dimension. उसके बाद हम multi-dimensional we'll also look into it. Right? But at a starting point we'll study only 1 dimension, that heat is getting transferred in only one direction. ठीक है. So this is conduction, right? ठीक है। कन्वेक्शन में क्या होता है ना, कन्वेक्शन में तुम्हारा होता है एक, लेट्स से दिस इज सॉलिड, सॉलिड भी हो सकता है, फ्लूइड, फ्लूइड भी हो सकता है। ठीक है। तो कन्वेक्शन इज मोस्टली यू नो ट्रांसफर, इंटरफेज है, इंटर सॉलिड से लिक्विड ट्रांसफर, या वन लिक्विड से अनदर लिक्विड ट्रांसफर, दैट इज वेयर कन्वेक्शन यूजुअली प्लेज अ रोल। ठीक है। सो फॉर एग्जांपल लेट अस कंसीडर कि ये एक सॉलिड स्लैब है, इसका सरफेस टेम्परेचर, so दिस सॉलिड स्लैब इज इन कांटेक्ट विथ फ्लोइंग फ्लूइड। लेट्स से तुम्हारा जैसे हीट एक्सचेंजर में होता है जैसे, तो और और दिस एग्जांपल ऑल्सो, जैसे हमने यहाँ पे देखा, यहाँ पे जो है ये जो है तुम्हारा, ये सॉलिड है, ये भी सॉलिड है, ये भी सॉलिड है, लेकिन ये तुम्हारा कुछ फ्लूइड है। सो दिस पार्ट में कन्वेक्शन होगा, इस पार्ट में कंडक्शन होगा, इस पार्ट में कंडक्शन होगा, इसमें अगेन कन्वेक्शन होगा। ठीक है। तो जस्ट प्रायर एग्जांपल इज, लेट्स से यू हैव अ सॉलिड, इसका सरफेस टेम्परेचर जो ये है, टी सरफेस, इस सरफेस टेम्परेचर, इसके ऊपर से फ्लूइड फ्लो हो रहा है, लेट्स से वाटर और लेट्स से एयर फ्लो हो रहा है, और इसका जो बल्क टेम्परेचर है वो टी इन्फिनिटी है, लेट अस अज्यूम। ठीक है। तो बिकॉज टी एस इज ग्रेटर देन टी इन्फिनिटी, इट इज गोइंग टू ट्रांसफर। ठीक है। इस डायरेक्शन में हीट ट्रांसफर होगा। रिमेंबर, हीट ट्रांसफर ऑलवेज ऑकर्स इन अ नेगेटिव, मतलब हाई टेम्परेचर से लो टेम्परेचर में हीट ट्रांसफर होगा। तो यहाँ पे हीट, बिकॉज टी एस इज ग्रेटर देन टी इन्फिनिटी, हीट इज गोइंग टू ट्रांसफर इन दिस डायरेक्शन। तो दिस, so ये यहाँ पे द थिंग की टू एम्फसाइज इज, इसके अंदर अगर हीट ट्रांसफर होगा तो वो होगा ड्यू टू कंडक्शन। ठीक है। इसके बल्क में इधर भी, इधर हीट ट्रांसफर होगा तो दैट वुड बी ड्यू टू कन्वेक्शन। और जो इंटरफेस है, यहाँ पे हीट ट्रांसफर होगा बिकॉज ऑफ कन्वेक्शन। ठीक है। तो दिस इज लाइक फर्स्ट मोड, दैट इज कंडक्शन, second mode which is convection, and the third is radiation, right? So radiation कैसा होगा, let's say एक radiation के लिए, let's say for example you have the sun है, sun is generating heat and it is spreading light in all the directions, right? Let's say these are the directions of radiation, और radiation excreted by sun, और अर्थ के लिए, अर्थ के ऊपर ऐसे रेडिएशन आ रहा है सन का। ठीक है। तो दिस इज नथिंग बट पार्ट ऑफ, क्योंकि यहाँ पे मीडियम नहीं है, अगर तुम कंडक्शन में देखो तो दिस इज अ मीडियम, सॉलिड मीडियम। कन्वेक्शन में देखो तो यहाँ पे लिक्विड एक्ट एज अ मीडियम, वेयर एज इन रेडिएशन देर इज नो मीडियम, एवरीथिंग इज वैक्यूम। ठीक है। तो ओनली part of the only way by which heat can transfer without needing a medium is nothing but radiation. So radiation में it is very important to understand something called as a view factor, मतलब how much amount of area, uh, जैसे फॉर एग्जांपल ये रेडिएशन आया, सो ये रेडिएशन इस पार्ट में पड़ा, सो दिस इज, सो द कौन सा पार्ट ऑफ इंसिडेंट रेडिएशन इस पे पड़ रहा है, सो वॉट एवर अमाउंट ऑफ हीट इट इज गोइंग टू एब्जॉर्ब और इट इज गोइंग टू सी इज अ फंक्शन of not only the amount of radiation but also the area बोलो या volume बोलो, so that is nothing but view factor. So this also we'll see if time permit, view factor. ठीक है। So now this is the course format which we are going to study. So conduction, so we'll not lot of time, so conduction is very important for fundamental understanding. So we'll spend 7 lectures. So these 7 lectures could be 7 into 1 hour or 7 into 1.15 hour. ठीक है। So I have planned it like this, देखते हैं कि whether we can achieve it now. So in that conduction phenomena, what we are going to study is 1D. So first of all, we are going to study 1D steady state, problems. Couple of examples of this will completely describe the system, will quantify how heat is getting transferred, what is the amount of heat which is getting transferred, and how do we find the temperature profile. So whenever heat transfer is there, there are two very important things which we have to find. That is, what is the amount of heat transfer? What is the amount of heat getting transferred? एक, number two, what is the temperature profile? टेम्परेचर प्रोफाइल। तो जो ये दो चीजें हमेशा कोई भी मोस्ट ऑफ द क्वेश्चंस फ्रॉम एग्जाम पर्सपेक्टिव, अगर आप ये दो कर पा रहे हो इसका मतलब यू आर हीट ट्रांसफर इज स्ट्रॉन्ग। So we are going to answer these two questions for each of the system. 1D steady state system, right? 2D steady state system. ये steady state क्या होता है? That also will study. What is this 1D? That also will study. That what is 2D? That also will study. What is this transient, heat transfer? ट्रांजिएंट हीट ट्रांसफर का एक एग्जांपल है कि लेट्स से यू हैव अ स्फेरिकल बॉल, लेट्स से ऑफ आयरन, उसको आपने बहुत हीट किया, लेट्स से टिल 300 केल्विन, 300 डिग्री सेंटीग्रेड, और उसको आपने सीधा पानी के बॉल में डाल दिया। तो नाउ वॉट एवर हीट ट्रांसफर इज गोइंग टू हैपन, दैट इज गोइंग टू बी अ ट्रांजिएंट हीट ट्रांसफर। ठीक है, तो दैट मीन्स टेम्परेचर इज गोइंग टू बी अ फंक्शन ऑफ टाइम। बेसिकली इसका ये मतलब है, एंड स्टेडी स्टेट का मतलब है कि टेम्परेचर इज नॉट गोइंग टू बी फंक्शन ऑफ टाइम। ठीक है, so that is what we are going to study, around 7 lectures. Then we are going to study, convection is going to take a lot of time because many, properties come. So convection we are going to study for about 12 lectures. So here we are going to study boundary layer terminology. For example, specific property, let's say for example, एक pipe है which is of cylindrical nature. तो उसमें you want to find what is the heat transfer or how this heat transfer is connected with momentum transfer, how this momentum transfer is connected to mass transfer. So there are various terminology, various boundary layer, boundary layer analogies. जैसे डिटस बोल्टर इक्वेशन होता है, उसके बाद डिटस बोल्टर इक्वेशन वो इस पार्ट में आएगा, एक्सटर्नल फ्लोज में आएगा, कि सिलेंडर के ऊपर से, लेट्स से फॉर एग्जांपल दिस इज अ सिलेंडर, इसके अंदर से फ्लूइड इज लिविंग, फ्लूइड इज फ्लोइंग। तो इसके लिए आएगा टर्मिनोलॉजीज, हाउ हीट ट्रांसफर को एवरेज हीट ट्रांसफर कोएफिशिएंट एंड एच एन एच बार आर रिलेटेड टू सम डायमेंशनलेस नंबर। ठीक है, प्रांड्टल नंबर एंड आई थिंक म्यू सी पी बाय की। ठीक है, रेनॉल्ड्स नंबर एंड प्रांड्टल नंबर, डिटस कोल्ड एच एन एच बार एज अ फंक्शन ऑफ रेनॉल्ड्स नंबर एंड प्रांड्टल नंबर। सो दीज आर ऑल वी आर गोइंग टू स्टडी। ठीक है, व्हाट इज द एक्सटर्नल फ्लो? एक्सटर्नल फ्लो मतलब ऐसे आएगा, और ये सिलेंडर है, ये दूसरा सिलेंडर है, और इसके ऊपर एक सिलेंडर के उन दोनों के बीच में जो गैप है उनमें फ्लूइड फ्लो हो रहा है, राइट? तो दैट वुड बी समथिंग कॉल्ड एज एक्सटर्नल फ्लो। इंटरनल फ्लो होगा ये टाइप ऑफ सिस्टम, फ्लो इनसाइड द ट्यूब, एंड देन फ्री कन्वेक्शन। फ्री कन्वेक्शन इज नथिंग बट नेचुरल कन्वेक्शन। ठीक है, नेचुरल, बिकॉज दैट व्हिच हैपेंस बिकॉज ऑफ द डेंसिटी डिफरेंस, नेचुरल कन्वेक्शन। ठीक है, फेस चेंज लाइक आई सेड कि हम boiling and condensation will also take, so it is not a very big thing, it's not going to take time. Most of the time would be on convection and radiation, right? Radiation is going to take 6 to 7 lectures. So in that thing we are going to study what is the black body, what is the absorptivity of black body, what is the emissivity of black body, what is a gray body, what are the view factors. These are all things. Let's say for example, ऐसा एक wall है, ये एक wall है, और इसके बीच में कुछ रेडिएटिंग सोर्स है, सोर्स ऑफ रेडिएशन। ठीक है, इसके ऊपर जो भी लेट्स से इंटेंसिटी I1 का रेडिएशन पड़ा, सम पार्ट ऑफ दैट एनर्जी इज गोइंग टू एब्जॉर्ब, इसकी वजह से इसका टेम्परेचर बढ़ेगा। सम पार्ट इट इज गोइंग टू रिफ्लेक्ट, एंड सम पार्ट इट इज गोइंग टू ट्रांसमिट। So how are these correlated? That is where black body and gray body comes into picture. So these are all the things which we are going to study. And then at the end, if time permits, we'll study the heat exchanger, which is very, 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 very important from any perspective. If you want to go industry, heat exchanger is very important. Interview may everybody will ask heat exchanger. If you want to go gate, one question will always be from heat exchanger. Pakka, one question. Minimum one question on heat exchanger. Will always come in gate mostly. ठीक है, so this topic is very important. ठीक है, तो आज के पार्ट में इतना ही। किसी को कुछ डाउट हो तो दे कैन आस्क। आज बस इंट्रोडक्शन है, तो आज ज्यादा नहीं करेंगे। दिस विल ओनली बी द थिंग व्हिच वी आर गोइंग टू If anybody has any question, they can ask.
So next class will be tomorrow, right? Monday.
Tomorrow, yeah. तो उसमें हम क्या पढ़ेंगे? उसमें हम ये वाला पार्ट कवर करेंगे, 1D ट्रांसफर। ठीक है, तो इसमें जनरलाइज एनर्जी बैलेंस, जैसे फॉर एग्जांपल यू नो जनरलाइज एनर्जी बैलेंस कैसे करते हैं, उसके बाद उसका हीट जनरेशन टर्म वगैरह सब क्या होता है, जनरलाइज हीट बैलेंस इक्वेशन, ये सब हम स्टडी करेंगे। दैट विल बी टुमारो विल स्टडी। किसी को कुछ डाउट हो तो पूछ सकता है। अगर तो इंग्लिश, शुड आई गो फॉर इंग्लिश और शुड आई गो फॉर हिंदी? आई फील कि मैं इंग्लिश ज्यादा बोल दिया। एनीबडी हैज एनी डिफिकल्टी विद इंग्लिश?
अरे यार
No,
तुम
sir.
लोग अनम्यूट करके बता दिया करो अपने आप।
या बिनी, आई थिंक बिनी वाज सेइंग, बिनी कुछ बोल रहे थे।
Both Hindi and English will do, and English will also do.
So the way I did is okay, right?
So that's okay.
That okay, right? Okay.
और कुछ फीडबैक?
या किसी को कुछ टाइमिंग इशू या कुछ दूसरा इशू?
No, sir.
फ्लो वगैरह ठीक है ना? आई एम नॉट गोइंग टू फास्ट, राइट? अगर मैं कभी भी फास्ट जाता हूँ तो ऑलवेज यू कैन इंटरप्ट एंड आस्क टू स्लो मी, बिकॉज आई टेंड टू बी वेरी फास्ट। तो मुझे रोक के बोल सकते हो कि यू आर गोइंग टू फास्ट, सो आई जस्ट फेस इट डाउन।
We will upload the lecture slides and videos on the Google Classroom, ठीक है? तो वो सब लोग ज्वाइन कर लेना। आई थिंक सबने ज्वाइन कर लिया होगा।
एंड गुड थिंग इज तुम्हारे लिए कि only 7-8 people are joining, so you can individually also ask question. We can spend time on that also. ये अच्छी चीज है तुम्हारे लिए, मतलब you guys, because if it is 60 people, 70 people would have joined, then it becomes a bit difficult to answer each and every question. But because less people have joined, so agar personal, you can ask any question and then we can spend some time, and unless you clear that doubt, we can spend considerable amount of time for that. Okay, so that's an advantage, yes, if you take it, use it in the right manner. Okay. क्या श्रेयांक, you were saying something?
हाँ मतलब किसी को कोई डाउट है तो बताओ, नहीं तो then कल मिलते हैं इसी
Yeah.
टाइम।
Yeah.
कल मंडे इज फाइन विद एवरीवन?
Yes, sir.
Yes, sir.
किसी को कोई दिक्कत किसी को? मतलब फ्राइडे, संडे एंड मंडे।
Friday को fluid mechanics, Sunday and Monday heat transfer.
Process calculation.
Process calculation after I think we do heat transfer, then we are going to plan, right now? So yeah,
हाँ हाँ
क्योंकि it becomes difficult for us to take two subject, तो हमारे लिए difficult हो जाएगा इसलिए।
एंड तुम्हारे लिए भी डिफिकल्ट हो जाएगा एक साथ।
तीन सब्जेक्ट एट ए टाइम करोगे तो फिर मिक्सअप हो जाएगा। ठीक है।
और कुछ बोलना है किसी को?
No, sir.
ठीक है देन आई
Yeah.
थिंक वी शुड स्टॉप रिकॉर्डिंग भरत।
Yeah. Thanks for joining. Okay. Now how do I?
Thank you, sir.
Yeah.
हाँ बोलो बोलो, कोई कुछ बोल रहा था ना? सूरज।